Hello, chemistry students. We have done a lot of work so far this semester studying individual elements, and today we are going to begin our conversation about what happens when two elements or more bond together. Now, there are several different ways elements can bond. They can bond ionically, covalently, or they can have metallic bonds. We're going to go over the definitions of those three bonds today, but first, I would like to review with you the types of elements on the periodic table. So the three types of elements are nonmetals, metalloids, and metals. You can take that blank periodic table that we worked on last chapter, or you could print out a new one and just highlight this for yourself. This stair-step structure that I've drawn here is sort of the split between the nonmetals and the metals. And along that diagonal line, that's where the metalloids exist. It's going to be important that you know where the nonmetals, metals, and metalloids are, because that determines the type of bond in the molecule. Okay, so the first type of bond is an ionic bond, and we've been talking a lot about ions this semester. So ionic compounds are formed from metals and nonmetals. So metals are over here in the green. There are a lot of metals, and over in the blue, you'll see the nonmetals. So when two of those combine, it forms an ionic bond. Nonmetals and metals. That's an important fact to know. They involve the complete transfer of electrons. So you can see that in this picture here. We have the neutral sodium atom and the neutral chlorine atom. The electron transfers from the sodium to the chlorine, and then we have two ions after the electron completely transfers. Ionic compounds are always neutrally charged, so the positive charge equals the negative charge, and they are represented by formula units. So you would represent this compound as shown down here, NaCl, but they don't exist as separate sodium chloride units. They are arranged in patterns of positively and negatively charged ions, as shown in the picture here. So you just have a large three-dimensional lattice of positive and negative charged atoms that are all sitting right next to each other. Some properties of ionic compounds: they are crystalline solids at room temperature. I'm sure you've seen a salt crystal before, like table salt. All ionic compounds look like those types of crystals. Some of them have different shapes and colors, but they're all crystals. They have very high melting points, and they can conduct an electric current when melted or dissolved in water. The next type of bond is called covalent bonding, and it only happens with two nonmetals. Covalent bonds form molecules where ionic bonds do not form molecules. And they involve the sharing of electrons between atoms. So let's take this bond right here, for example. The two electrons inside that circle are being shared between the oxygen and hydrogen atom. If you take a look at the valence shell of this oxygen atom, you will see that there are 8 electrons in that shell. So it's got a full octet. And then those electrons also will be counted in the valence shell of this hydrogen atom. So this shell is full because its main level 1 only holds 2 electrons. So this one is also full. The hydrogen atom on this side also has a full shell. If I were to draw a picture of where these electrons are existing, it's not just in that little pocket between the elements. You can imagine them as let's talk about this one right here. You can imagine this guy as traveling around oxygen a couple times, and then it will pop over here to hydrogen. And then around oxygen, and then out. So it's shared between the two. Sometimes it's on the oxygen, sometimes it's on the hydrogen, but overall, the entire molecule is neutrally charged. And they are represented by molecular formulas. Molecular formulas look a lot like the formula units of ions, but they actually represent a complete molecule that's existing by itself. Molecules don't necessarily form lattices. Sometimes they do, and sometimes they don't. It just depends on what state they're in. So you would represent this one as H2O. So that's telling you that there are 2 hydrogens for every 1 oxygen in this molecule. And you would know that this is a covalent bond because you could look at your periodic table and see that both oxygen and hydrogen are nonmetals. Properties of covalent molecules is they can be solids, liquids, or gases at room temperature. They have very low melting points typically, and they are poor conductors of electricity, which would mean that they're really great insulators. Finally, the last type of bond is metallic bonding. Metallic compounds are formed from metals. So it's a metal-metal bond. And typically they're formed from the same metal. So in the example I have here, it's a bunch of aluminum atoms in a lattice. And they're made up of free-floating valence electrons and positively charged metal ions. So you have these positively charged ions, and the electrons around them are just floating in this large lattice of metals. So we're not going to work with metal bonds a lot, but it is important that you know that this is a type of bond that can be formed, and it typically is formed with the same metal. Although if you were to incorporate 2 types of metals in a metal bond, it's called an alloy. So so many of these would be a different metal in an alloy.